Okay, so we're looking at some of the homework from section 1.8. The ones that I graded number 46 and number 64, and I just gave you that homework back. So let's take a look at 46A. It says find f of g of 1. So if we're trying to find f of g of 1, and this is the f of x function graph, and this is the g of x function graph, we need to find g of 1 first, because that's the inner part of this composition. And g of 1 says look for where is there 1 on the x-axis, and go up and see the height. It might be helpful if you're looking at your book. Can you take a look at the book with me, please? Page 90 in your book. Chris, page 90. All right, and so with this, you see that g of 1 is going to be what height? 3. So if g of 1 is 3, that means I'm really trying to find f of 3. So now I go to the f function, and I say, well, here's 3. How high up does it go? And how high up was it? 2. Are we okay with that? And then for part B, it was saying find g of f of 3. So in this case, I would want to, again, work inside out, so find f of 3 first. F of 3 we just said was equal to 2. So that means I'm really trying to find g of 2. So now I go here. What did 2 go to on the g function? 2. Are we okay with this? Okay. The other problem that I asked you, the other problem that I graded was number 64. So take a look at 64. We're on page 92. It says a pebble is dropped into a calm pond, causing ripples in the form of concentric circles. The radius is given by r of t equals 0.6t. And the area formula in terms of the radius would be pi r squared. They asked you to find and interpret a of r of t. And so that means you're going to plug in the r of t function in wherever you see the r, right? R of t is 0.6t. So I want to take this 0.6t and plug it in right here for this r. So I'm going to write pi times 0.6t quantity squared. And when I do that, I end up getting pi times 0.36 times t squared. This is your a of r of t. Well, that's great, but I also asked you to interpret. And so the interpretation would be if you enter what, you can get what. This is giving you the area based on the what? The time, right? This is the area of your circle based on the time since the pebble was dropped. That would be your interpretation. Does that make sense? Okay. All right. Anything on this 1.8 homework that we should talk about before we talk about 1.9? Okay, so what do you want to look at from 1.9? And while you're getting your questions ready, I'm going to pause this. Okay, so now we're looking at some questions from section 1.9, and one of the questions was, just asking for clarification on how can you limit the domain on a function if you're graphing. So for example, if I wanted to graph x squared, but I only wanted to see it for x greater than 0, right? Like there's my x squared, but if I only wanted to see, for example, this much of it right here, then I'm going to want to use a piecewise defined function to do that. So let me add a new page to this document, a graphs page. Let me get rid of that ink. Okay, so this time I want to push this button right here. That's to the right of the 9. And I want this piecewise right here, the one that looks like a 3x3. And it's going to ask me how many pieces do I want. I'm going to say I want 1 piece. And that's when I can just say, oh, I want x squared. And I only want that for x greater than or equal to 0. So I'm going to say control and the equal sign. So I can get a greater than or equal to 0. And now I see I can get just that p squared. Does that make sense? Okay, but again, most of these I think you're asked to do on graphic paper. Are we okay with this? All right, another question that came up was how do you tell if two functions are inverses or not? And so let's talk about that. That's not the one I was on, I don't think. That's the one I was on. Okay, so if we have two functions, let's say f of x is 2x minus 7, and let's say g of x is x plus 7 over 2. How do we determine if these two are inverses of each other? Well, you would want to show that f of g of x, when you do the composition, that that's equal to x. So show that f of g of x is equal to x, and show that g of f of x is also equal to x. So let's try that. If I'm trying f of g of x, that means I really want f of my g function is x plus 7 over 2. So that means I'm going to put the x plus 7 over 2 wherever I see an x in the f function. So I'm going to have 2 times x plus 7 over 2 minus 7. Does this look okay? At this point, I'm going to show how I can simplify, and what I don't want you to do is say, oh, the 2's divide out, the 7, okay, equals x. If I saw that on a paper, I would have to take off points, because I need to know that you know in what order this happens. So let's not go slash, 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 slash. Instead, I would say, what can I divide out or subtract off first? The 2's. So I'm going to divide out the 2's, and then I'm going to write this all-important step to get full credit. And then I'm going to say, oh, now I can subtract off the 7's. Now I'm equaling x. Is this okay? But remember, you also need to show that g of f of x is also equal to x. So let's try that. If I do g of f of x, that's the same as g of, my f of x function is 2x minus 7. That means I want g of 2x minus 7, which means I need to go to my g function, and wherever I see an x, like right here, I'm going to take out that x and replace it with 2x minus 7. So I'm going to have 2x minus 7 plus 7 over 2. Everybody agree? Now what would I do first? Divide out the 2's or subtract off the 7's? Subtract off the 7's, so I have to come first. So I'm going to get 2x over 2. I'm going to write that step so I can get full credit. And then I'm going to show that the 2's divide out, and I'm left with x here as well. That proves that f and g are inverses of each other. Are we okay with this? Okay. All right, and I am pausing again, and you guys are... Okay, so if we're looking at number 45, function was f of x equaling square root of 4 minus x squared. If we're trying to find the inverse, we would rewrite f of x as y. Then we're going to switch the x and the y, and we're going to solve for y. We're going to do that by squaring both sides. And so I get x squared equaling 4 minus y squared. We need to solve for y, so if we subtract 4 from both sides, we would get x squared minus 4 equals a negative y squared, and divide both sides by a negative 1, for example. I'm getting negative 1x squared plus 4 equaling y squared. I can rewrite that as 4 minus x squared equaling y squared. Take the square root, and we're right back to where we started, which is square root of 4 minus x squared. Right, but one thing that we should point out is that the original problem had a limit on their domain. It had to be between 0 and 2. Okay. If you remember from our work with circles, we had this as the standard form of a circle, correct? And if h and k were both 0, that means the circle was centered at where? The origin, and it would have a radius of r, or whatever that was. And so if I was trying to, and I think we might have even done this, somebody might have asked in this class, how do we graph this on the calculator? Did someone ask in this class? Okay, so you know that we'd have to solve for y. So I would get y squared equaling r squared minus x squared. Take the square root of both sides, right? Don't forget your plus or minus though. And so we would end up with y equaling plus or minus square root of r squared minus x squared. And that's great. The positive square root would give us the top half of the circle. The negative part would give us the bottom half of the circle. Agreed? So without any kind of limiting factor, if they had not said, oh, we want to limit it from 0 to 2, if they had left that part off, what shape would we see? Semicircle would be the top half of the circle, the whole thing, right? But since they limited it from 0 to 2, we only get that upper right corner of the circle. Everybody agree? And it turns out it is its own inverse. Are we okay with this? Did they have to limit it? If they had only given us the top half without the limiting, could we have found the inverse of this, and would the inverse have been a function? No, it would not, because it fails the what? Horizontal line test. So that's why they had to limit it from 0 to 2. They could have limited it from -2 to 0, but then it wouldn't have been its own inverse. You know what I'm talking about? Like if they had said, oh, have that function, but just have it right here, like -2 is less than or equal to x. If they had made this the limiting, then where would the inverse have ended up? What quadrant? Would it still be there in quadrant 2? Matthew, where would it be?
4.
Why?
Because it's a function of the line.
Now it's going to have to be reflected over this line, y equals x, so the inverse would end up down here. Does everybody agree? So it still would have an inverse. It wouldn't be its own inverse, like this one from problem 45. This one's graph. The original function looks like this, and it is its own inverse, right, over that line. It's its own inverse, and it's its own reflection over the line y equals x. Okay. Okay, so we are looking at number 49. Here's the original function. We're going to rewrite f of x as y. We're going to switch the x and the y. So it's looking like this. And then our strategy, we got to solve for y. So let's multiply both sides by y minus 2. And at this point, the y minus 2's divide out on the right, and here we can distribute, and we'll get x, y minus 2x equaling y plus 1. If we're trying to solve for y, we should at least try and get the terms with y in it on the same side. So perhaps we can subtract y from both sides, and maybe get rid of this 2x by adding 2x to both sides. So that should give us x, y minus y on the left, and 2x plus 1 on the right. Does that look okay? And then here's the next tricky thing. I would say, I see we're trying to solve for y, and I see y in 2 places. I only want to see y once. So the best way to get it only written once is to factor it. So I'll end up with y times the quantity x minus 1 equaling 2x plus 1. Now I can just divide both sides by x minus 1, and I get y equaling 2x plus 1 over x minus 1. And I guess I circled that one, but I could write it now as an inverse of x equaling 2x plus 1 over x minus 1. Are we okay with this? And then, Chris, looks like you graphed these.
Yeah, I just plugged in points for both the inverse and the
Okay, so if we're going to look at the domain and range for these, I think that might be easiest at this point to do with a graphs page. So let's type this function in on a graphs page. Grab your calculators. I'm doing control divided by, and I want x plus 1 over x minus 2. Is that correct for my original? All right, notice the graph looks like this. The domain is going to be anything that I can plug in that's not going to make this function undefined. So what number is going to make this function undefined? 2. So the domain is going to be all real numbers not equal to 2. Agreed? All right. So I could say domain of the original is like negative infinity to 2, not including the 2, union with 2 to positive infinity. Agree? Okay, what about the range? Well, how far down does the graph go? How far up does the graph go? Are there any missing values that we're never going to get out of the function? What do you think? It's never going to get a height of 2? I think what we're not going to get out of this function, I mean, it looks to me like we have a horizontal asymptote. We're going to learn about vertical asymptotes and horizontal asymptotes in section 2.6, but I think that it's impossible to get a 1 out of this function, to get this function to equal 1. Like, what would I plug in for x so that my numerator is actually equal to my denominator? Is that going to be possible? No. So I think that we're never going to get a height of 1 out of this function. So I would write that the range is going to be negative infinity to 1 union with 1 to positive infinity, which means all x is not equal, I'm sorry, all y is not equal to 1. What about our inverse? If we put our inverse on this that we worked out, that was this one, 2x plus 1 over x minus 1. So I'm adding, no, I don't want to do that. So control divided by, what was it? 2x plus 1 over x minus 1. All right, so now, so that's our inverse graph. And this graph, I can see that looks like a nice inverse, right? But again, here, if we want to find the domain, it's all real numbers except I can't plug in 1, right? So my domain is going to look just like my range from my original, right? And looks like it's got a horizontal asymptote higher, right? It's got a little horizontal asymptote here at 2. So it's impossible to get this function to equal 2. You're never going to get a 2 out of that function. The domain of the original becomes the range of the inverse, and vice versa. Are we okay with this? Okay, let's take a look at number 60. Morgan? Okay, so if we're looking at number 80, here's the data, and the question was asking you, does the inverse exist? How do we tell whether the inverse exists? If we were to plot these points, would they pass a horizontal line test? How do you know it would pass a horizontal line test? Remember, it's going to pass a horizontal line test if it's 1 to 1. You already know that every x has to go to 1y, but 1 to 1 means every y comes from just 1x. Does that make sense? Every y goes to just 1x. Is that the case? Yeah, we don't have any y values. We don't have any y values here being repeated. There's no repeats. So yes, the inverse exists. And then for part B, it says if f inverse exists, what does it represent in the context of the problem? Well, if we were to write a function f of x equaling something, right? Then it would be, x would be the number of years. You plug in the number of years, and I'll tell you the number of digital cameras sold. That would be the original, right? So what would the inverse be? Now, if I plug in what, you'll tell me what? All right, so if you tell me the number of cameras sold, the output will be what year it was. Does that make sense? All right, and then it says if f inverse exists, find f inverse of 1825. That's saying if 1,825 cameras were sold, then what year was it? Year 10, right? And then it says if the table was extended to 2004, and the factory sales of the digital camera for that year was 2,794 million, would the inverse exist? So if I add a 2794 here, what do you think, Lily?
No, because I'm 2x coordinates would go to 1 y.
All right, then I have 2 different x coordinates going to the same y. That makes it not 1 to 1 anymore. The horizontal line test would fail, and the inverse would not be a function. Are we okay with this? Okay.
One of them